Bueno, estamos acá en otra retransmisión. Bueno, en otro video viendo cómo SpaceX logra lanzar su cohete de vuelta, pero ayer se canceló, lastimosamente se canceló y no tuvimos lanzamiento y bueno.
Minutes away from the first flight of SpaceX's next generation vehicle, Starship version 3. Yesterday's launch attempt was scrubbed due to a hydraulic pin on the pad tower that wouldn't retract. But good news, the teams were able to resolve that issue, and we're proceeding ahead with attempt number 2 and blue skies to boot. I'm Kate Tice, Senior Manager of Quality Systems Engineering.
And I'm Jake Berkowitz, a Lead Propulsion Engineer. And today we're...
Wet dress rehearsal yesterday.
Yeah, that's right. And everything we've learned from the previous 11 flights to make a vehicle capable of full and rapid reusability.
We're debuting a new launch pad, new booster, new ship, and new engines, just to name a few.
Yeah, that's right. And as a member of the Raptor team, I can tell you we're all super excited to finally see the newest generation of Raptor engines, also V3, take flight today.
I love that view looking up under the Super Heavy. Now, Raptor and Starship version 3 are designed to enable us to send payloads and eventually people all the way to the moon and Mars.
Yeah, and in the meantime, we're planning to put Starship to work on future flights by launching bigger and more powerful Starlink version 3 satellites, which aim to substantially increase capacity in orbit, strengthen the network, and deliver an improved experience for customers.
Now, turning our attention back to today, our primary objective for Flight 12 is to put these new redesigns all together in a real live flight environment. From the outside, a lot might look familiar on Starship, but beneath the surface, it's all new. As we've said before, Starship is still a developmental program. What we're doing today is a test. We launch to learn, and we test like we fly.
Yeah, and it's really the data we're expecting to get back from today's flight that will bring us closer to making Starship operational and unlocking the next generation of our future in space. So, no matter the outcome of today's test flight, excitement is guaranteed.
Now let's head a couple floors upstairs where Dan Hewitt is just outside our Launch Control Center. How's it going up there today, Dan?
It's going great, Kate. Everybody, welcome back for round 2. I'm Dan Hewitt with SpaceX Communications. We're looking good for a launch today. Do you want to do a quick summary, though, of what we saw yesterday, how we got back to launch? It's a really good example of all of the different moving parts that have to work together to get a rocket off the pad. About halfway up that tower, you see an arm that holds all of the propellant connections into the ship. It's also set up so it kind of pushes against the ship to help make sure that we have a really good connection, and it stays attached when we unlatch that quick disconnect. There's a pin in the arm near where that attaches to the tower that has to be removed before the arm can swing away for launch. It's important to remember there's a lot of benefit to not release the arm too early or too late, and a lot of hardware that has to work in concert in very, very short time frames. We started to unpin it. Releasing that tension caused a motion in the arm that triggered a hold, and that put the pin back in. Then that got us into a bit of a tug of war between systems on the tower that rely on hydraulic pressure to work. Really, the arm trying to keep its pressure on the ship and trying to pull that pin out. You saw we made a couple of attempts to fix the issue, eventually got the pin to start retracting again, but hit the same motion hold. Ultimately ran out of time. The team, though, made some hardware, some software changes to get us into a better position to fly today. We had the tower team up there last night. They welded in some hardware that's going to cut down on the motion of the arm as it's pushing back when the pin's released. And getting all the data we saw on how this hardware interacts in those critical moments went in, looked at our software, all of our logic, see where we were overly conservative, where we may have had holds built on the wrong readings or the wrong times. Overall, though, really fast work by the engineering teams put us in a position for flight today. Heroic work by our logistics teams to get all the propellant out there. But things are looking really good for launch at the moment. Right behind me, all of the flight controllers on console, looking at the rocket, looking at the pad, looking at the range, all the systems as we count down to liftoff. Propellant load is underway. You can see the rocket getting frosty. We're on track to launch at the top of our window at 5:30 p.m. Central Time. Weather has been gorgeous. Thank you to everybody who was outside yelling at clouds that got us weather yesterday. It extended into today, and we are looking at a green range right now. Functionally, today's countdown, identical to yesterday. It looks very similar to previous Starship flight tests. Some minor differences in timing on things like when we start propellant load, when the water starts flowing on the diverter, when our engines start up. But all the hardware is new booster, new ship, new engines, new pad. Let's do another quick look at everything that's debuting today with Starship version 3. As Kate noted, some of the outside will look familiar, but we've made extensive upgrades across the entire system. Big picture, because Starship's still very, very big. It's just over 407 feet tall, fully stacked, a little bit taller than version 2, have more propellant in both stages. On the bottom half, our super heavy booster has some visible structural changes on the outside. On its top, we've got an integrated hot stage now. Got rid of the one-time use one, so we're doing that for reusability. The ship's Raptor engines are going to be igniting directly into the top of the booster. That's where you're looking right now. All of that force and heat offset by the pressure inside the booster's fuel tank and a thin layer of non-structural steel. The grid fins on the booster, which we used to steer on descent, went from 4 down to 3, but we made them 50% larger. Higher strength, also use them for lift, and we'll use them for catch on future missions when we bring the booster back. We redesigned the fuel transfer tube inside the booster. That's what's sending all of that massive amount of liquid methane down to those 33 engines. Lets us light all 33 at the same time and have faster, more reliable flips. The bottom of the booster looks very different with those Raptor 3 engines. We deleted all of the bulky engine shrouds from previous generations, all of the prop, avionics hardware, everything for that super tightly integrated now, protected by much slimmer shielding. Up on the second stage, Starship version 3 designed to carry massive orbital payloads up to 100 metric tons to Earth orbit the Moon and Mars. Biggest changes inside the vehicle itself. Propulsion system got a complete redesign, increased our propellant take volume, improved our steering on orbit. In the payload bay, the PEZ dispenser supercharged. That's going to increase the deploy speed for each of our satellites. We've got 22 payload deployables in there today. It's the heaviest we've ever carried on Starship. Eventually, we'll have up to 60 planned of those Starlink V3 satellites. Also on the ship, we added docking ports. There's 2 right below the payload bay door, 2 near the bottom. That's going to enable us to have Starships link up in orbit for propellant transfer. Also modified the connection point in the ship to facilitate that. So a lot of upgrades tip to tail, and still powering it all is the Raptor 3. Now, those engines are manufactured in Hawthorne, California, tested in McGregor, Texas, redesigned their ignition system, bumped up the thrust in the sea level and the vacuum engines, and then took all of the sensors, feed lines, controllers, everything that was kind of the busy sections around Raptors 1 and 2, and either deleted them or internally integrated and protected them inside the engine. That dramatically cut down on the weight, made it easier for those to manufacture. So, just an incredible amount of effort from the world's best engineering team getting this rocket to the pad, ready to launch today. I'm going to stop talking for a little bit. That was a lot. Send it back down to Kate and Jake for more on Pad 2.
Yeah, so like Dan was just saying, the team has been working hard on a brand new rocket, but we also redesigned the ground systems. And that brand new Pad 2 is making its debut today.
We took everything we learned from operating on Pad 1 to create this totally new launch pad. Pad 2 is optimized for full and rapid reusability. We've upgraded our propellant farm with much more storage and more pumps to enable super fast filling for launch and relaunch. And on the tower, we changed to shorter chopsticks. That's the black assembly there at the top of the tower, and that enables even faster motion to better track vehicles flying in for catch.
Yeah, and we also changed the actuators driving those chopsticks from hydraulics to 100% electromechanical, increasing their speed, redundancy, and reliability. On the ground, the launch mount was also completely redesigned, and if I had to describe it in one word, I'd say robust. But it's also smarter. We've separated the fuel and aux systems into different compartments and repositioned the booster quick disconnects to be out of the vehicle's plume during liftoff.
And as you can see there on your screen, we also have a new bi-directional flame diverter and a new top deck flame deflector to eliminate metal wearing down. So we said goodbye to the pancake. However, this will help us get to 0 refurbishment between launches. Now this pad is still built for maximum safety and fast turnaround because making life multiplanetary will require launching a lot of Starships. Now, it's currently T-minus 18 minutes and 38 seconds. We're going to hop over to Hawthorne for a moment for more on Starlink with Tyler Lionquist. Tyler?
Hey, Kate, thank you so much. I'm Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. We're excited to be back here in Hawthorne, ready for another attempt at a launch today. So as we talked about yesterday, on today's flight, we're deploying 20 Starlink simulators, plus 2 modified Starlink satellites, which our team internally refers to as Dodger Dogs, because they stretch the V2 Mini satellite propellant tank so that it sticks out from both ends of the satellite. And the Dodger Dog serves as a tech demo between the V2 and the V3 Starlink satellites, and acts as a platform for testing V3 components. Now, the larger V3 satellites aim to greatly expand our network's capacity, while V3 hardware is designed to support faster Wi-Fi and improved broadband speeds for our customers while providing significant capacity upgrades from the V2 Mini. So, in addition to delivering future V3 satellites to the Starlink network, Starship is also planned to launch our AI satellites. And as you may have seen during the TerraFab event in Austin a few months ago, Elon laid out the path to revolutionize cloud computing and AI infrastructure, leveraging the unlimited power of the sun, targeting 100 gigawatts to 1 terawatt of AI computing power annually. And from there, we're looking at connectivity beyond our planet too. Building on the technologies used to connect people on Earth, the Starlink team is exploring using Starlink to enable high bandwidth connectivity around the moon. With a constellation of satellites designed to connect to user terminals on the lunar surface, we could relay data back to our Starlink constellation in Earth orbit. So traditionally, deep space comms have relied on radio frequency transmission. But this new design would use lasers to relay data back to Earth, which can massively increase the bandwidth available to future lunar missions. We currently have thousands of lasers operating in our Starlink constellation around Earth, and deploying that technology around the moon could connect it with hundreds of terabits of capacity. Together, this could provide the connectivity backbone between the Earth and the moon, and enable gigabit connectivity anywhere on the lunar surface, providing data for rovers, habitats, and astronauts, and hopefully some incredible views for us back on Earth too. So all of that adds up to a lot of satellites, but the good news is there's still plenty of space in space. That said, the Starlink team takes space safety extremely seriously and works hard to encourage best practices across the entire industry so space stays open for as many people as possible. In fact, just yesterday, the Starlink team published a new update on
para mí en sí está mejor. Ahí estaríamos viendo lo que haría la Starship y el Super Heavy. Vemos la trayectoria de Starship. Pasa todo Cuba y las Islas Canarias. Pasa cerca de Brasil. Pasa por Sudáfrica. Pasa por el Océano Índico. Y Amerisa, cerca de más o menos cerca, se puede decir, de Australia. Bueno, estamos a 13 minutos. Ahí vemos cómo va la Starship y el Super Heavy. LOX significa oxígeno y CH4 significa metano. Estamos viendo las boyas que utilizan para grabar a la Starship cuando ameriza en el Océano Índico. Tienen un montonazo de cámaras. Estamos a 10 minutos de Ustedes no están escuchando lo que están diciendo, pero yo sí. Si de repente ven que estoy mirando tipo así, o estoy mirando otra cosa. Pero lo mismo.
Almost 10 years later, the ongoing construction, as you see there on your screen, and the development that will bring a second launch tower to Launch Complex 39A. It's designed to expand our capabilities to support Starship launches in the future, while also continuing to support Falcon Heavy missions from the original Apollo Shuttle Falcon launch tower.
Yeah, and we're not done. We're also building a Starship launch pad at Slick 37. And to support the uptick in future launches, there's Gigabay, a giant assembly and maintenance facility designed to prep Starships ahead of Florida launches. And when complete, this huge structure aims to hold 24 work cells in over 800,000 square feet of workspace. It's going to be a big building.
So much space.
So yeah, SpaceX's future in Florida is quickly taking shape with our very first launches on the horizon.
Exactly. A horizon that aims for regular trips to the moon. And speaking of moon, we've got another special guest for you today. Dan, I think the last time you and I were on a webcast with this person was Polaris Dawn, as he was performing the very first commercial spacewalk.
That's right, Kate and Jared. I don't know if today will be quite as cool as doing a spacewalk, but we're going to try our best to make it as exciting. Like, thanks for joining us here today, man. You had a heck of an entrance on the way in.
It's great to be here. Yep, certainly great to do a little bit of a flyby. I think they should accompany all the great rocket launches, and we certainly got a great rocket out there on the pad. But wonderful to be back, and no surprise, it's always changing here. It looks amazing.
I was going to say, it's been a couple of years. What was your impression flying in? It just the lay of the land.
Well, I think it was actually maybe 10 months ago. I was here slinging pizzas. I got a new job now, but it was. There's been so much that's changed even since then. Yeah, the facilities look amazing. All the housing that's coming in here, and of course, you got 2 orbital launch pads out there and a rocket that's just looking fantastic, especially from the air. It's good.
Yeah, you said you got a new job. It's been a slow start to your first 6 months. I mean, you only sent humans around the moon for the first time since the Apollo days. Bill and I kind of nerded out a little bit. Like, that was the last thing I worked on when I was at NASA, so seeing them go was just insane. Like, how's everybody feeling after the success of Artemis II?
Well, I'd say I have the best job in the world, and I certainly work with an unbelievable team. I mean, as you know, that mission was a long time in the making, so I got to show up at the right time to see everybody put all that effort to put it in action. But what a great mission. Those 4 astronauts, you couldn't have had better ambassadors for humankind to the stars. I mean, they really brought us all along for 10 days, and we're getting ready for what comes next. We're going to start stacking Artemis 3. We got a lot of the hardware in the VAB already. We're hoping to even get out to the pad before the end of the year, do another wet dress. So,
all right.
And we're looking forward to seeing this thing fly, because hopefully at some point in the not too distant future, we're going to join up in Earth orbit.
Yeah, what's coming up next, and ultimately, like, based on the moon, that's the big focus. Like, what's kind of the why? Like, why are we doing this for everybody?
Oh, well, I mean, and yes, we're certainly trying to get back to the moon. But what's coming up next? We're also building a moon base in parallel. Why are we doing that? Well, it's for a lot of the shirts I see around here, which is Occupy Mars. I mean, what a great opportunity! Go to the moon, return to the moon, build a moon base on the South Pole, interact with the water ice, right? Maybe work on some of those skills we're going to need when we're 4 days away from home, for what we might need someday when we're 9 months away from home. But we got other things coming up too. You got Nancy Grace Roman. That telescope's going to launch later this summer. There's a lot of great, exciting things going on at NASA right now.
Yeah, man. All right. Well, SpaceX, we're custom built to try and make life multiplanetary. We're super honored, excited to be part of this entire Artemis program. Really excited to see Starship, sending people to the moon, all of the different pieces working together. It's going to be a really exciting future.
Absolutely. Well, thanks for having me here. It's great to see everybody. Again, I know a lot of hard work leads up to a moment like this, so we're all rooting for you, and we're looking forward to meeting up next year in Earth orbit.
All right, man. Well, I'll let you jump back in there. Got about 4 minutes to go. I'll toss it back down to Kate and Jake.
Yeah, I think it's safe to say we could listen to you guys yap about the moon pretty much all day. It's so inspiring. inspiring to hear about the future of exploration on the moon. And if you caught the show yesterday, you also heard some more future space exploration news.
Yeah, that's right. From-2 mission commander Chun Wang will be one of the first humans to become an interplanetary traveler. Don't think I've ever said that word before. While also joining Starship's first mission to fly past the moon.
Yeah.
Incredible.
Amazing. In fact, that Dragon capsule that you saw there was Dragon Resilience. That is the same Dragon spacecraft that Administrator Isaacman flew in both Inspiration 4 and Polaris Dawn. So it's a good one. Now, Dan, we're now coming back into a terminal count again. Anticipation is definitely growing as we proceed towards our second attempt. Once again, this is the first flight. We're aiming to fly for the first time, Starship version 3. Massive upgrades across the vehicle that you see at the pad there, as well as the pad itself.
The good news is we've had a pretty quiet countdown today. We are looking at a green range still, not tracking any issues with our weather, with the vehicle, or with the pad for a launch. We are now getting into the phase where we're closing out prop load on the ship, and then booster is going to close out in about 15 seconds or so. Once we're fully done with this, you're looking at 11.5 million plus pounds of liquid propellant on board Starship and Super Heavy. We're going to get the pad itself ready, push back all of the propellant that's in those lines running from the farm up to the launch mount, just kind of harden the area and get it ready for launch. We're going to peek inside, hopefully see the engines do a little wiggle as we do our final steering check. That'll happen at T-minus 100 seconds, and then after we get through T-minus 40. If you tuned in yesterday, you're very familiar. If we need to hold, we can go into what's called rapid recycle, essentially, where we can hang out at T-minus 40 seconds. It's built in. We're only going to hold if there's an issue, not currently tracking one. They can pop up after we pass T-minus 40, but right now we're looking good. Hopefully going to move right past that.
And then once we do pass T-minus 40 seconds, a number of events will occur in quick succession. That is when the QD vent gate, or quick disconnect vent gate, will clear the gas commodity lines that connect the pad to the vehicles. Both the ship and the booster will configure their comm systems for flight and will rapidly run leak checks on gas and fluid tanks. And the booster goes to internal power, and its engines will get their final priming for launch, while the ship's engines begin their ascent bleed profile and arms the automatic flight safety system.
Yeah, and once we pass T-minus 40 seconds, we still have the ability to rapidly recycle the count under certain conditions back to T-minus 40 seconds.
Looks like we might be getting some engine wiggles here, as Dan mentioned earlier. These allow us to check out the thrust vector control actuators on these engines. It's important to make sure that they can steer.
Yeah, that's definitely right. And flame diverter on pad 2 activates at around T-minus 17 seconds and enters what is essentially the point of no return at T-minus 10 seconds. If we have a hold close to T-minus 17 seconds, there's a chance we could recycle, but the closer we get to T-minus 10, the lower that chance becomes. We just heard we're at T-minus 1 minute.
Yeah, so at this point in time, we're going to stop talking. We're going to let the rocket take over and listen to some amazing pad sounds of the first flight of Starship version 3.
25, 24, 23, 22, 21, 40. Hold.
All right, we are holding. We were just waiting for the fuel pushbacks to complete into the prop farm. We did hear that did just complete, so expecting them to reset that hold shortly.
Chequear todo.
Clock, the hold is reset, clock is rolling.
Tenemos
Flight directors go for launch.
29, 27, 26, 25, 24, 23, 22, 21, 20, 19, 18, 7, 16, 15, 14, 13, 12, 11, 10, 9, todos comenten. 8, 7, 6, 7, 8, 9,
Ignition.
2, 1, encendido de Starship Super Heavy, se levanta, se lo han logrado, vemos ahí como sale volando.
Pitching downrange.
tenemos despegue de la Starship.
Booster Raptor, chamber pressure nominal.
All right, we are T plus 30 seconds into flight, seeing 33 out of 33 Raptor 3 engines on booster V3, ascending over the Gulf now, coming up on maximum aerodynamic pressure.
Booster and ship, avionics power, telemetry nominal.
Systems looking good. We're just passing through the period of maximum dynamic pressure. A little over a minute into flight now. Vibrations chilling out here at Star Factory as we continue to watch Starship Flight 12 arc out over the Gulf. The next major thing coming up is going to be hot staging.
Booster prop systems
reminder, we do what's our version of MECO. Most engines cut off, so we're going to shut down all but 5 of the Raptor engines on the booster. And then after that happens, we're going to ignite the 6 engines on ship while it is still attached. We have clamps that hold the 2 together. Those are going to retract inside of that hot stage ring, kind of protect them. Looks like we had one of the engines go out, still flying on 32 of the Raptor engines. But again, once we get the hot staging, those 6 engines on the ship are going to ignite. We're going to do it in a little bit different of a sequence on version 3. Essentially, those 3 RVAC engines will ignite first. Almost immediately after, just one of those central engines is going to ignite, and that's going to give the booster a bit of a kick, sending it in a known direction, followed shortly after by the other 2. We're through MECO.
Huge separation.
La separación en caliente se separa el Super Heavy.
There you go. Successful hot staging separation. We are not seeing as many booster engines ignite as we expected for boost back, but we are seeing 6 good engines lit on ship. It looks like we just had an early boost back shutdown. Again, a reminder, the booster was planned to essentially head into the Gulf for a splashdown, but it has shut its engines down early on into boost back.
Se ha apagado un motor de Starship, uno vacío.
And we just see one of the RVAC, so we're now running on 5 engines on ship.
Ya podemos ir diciendo.
We do have engine out capability, so it's going to continue into its ascent. You got booster on the left there, ship on the right.
Está empezando a girar.
Ship avionics power and telemetry nominal.
We are not planning on bringing the booster back for this flight, as this was the very first time. All right, so we're about 3 minutes, 50 seconds into today's flight. Just a reminder that the ship planned to burn its engines for about 8 minutes and change. About 8 minutes and 11 seconds was our planned timeline for today. That could shift slightly as we do have 1 engine out, running on 1 fewer RVACs. Again, continuing to watch. So booster did not complete its boost back burn. We would not see all of the engines ignite that we expected. Are continuing to get some views from it, though. That's going to make a splashdown somewhere in the Gulf. Reminder, we clear air, sea space, everything for these launches.
No ha hecho nada malo. También vemos una nueva cámara del Super Heavy.
All right, so we are coming up on T plus 5 minutes. Ship continuing to fire 5 of the 6. Standing by for callouts, making sure ship's on its planned trajectory. Again, we are planning a suborbital trajectory for the ship today. Booster giving us some views as it continues to make its way back down towards the water. All right, so a little over 5.5 minutes in flight. Kate, Jake, you guys with me? It looks like Booster's starting to come in hot.
Yeah, we had the opportunity to stand outside to watch launch, and wow, that was incredible.
Yeah, that was really loud, really shaky, and I was actually surprised how fast the booster got off the pad, or the whole stack. That was quite incredible.
Absolutely. So we have views here from the booster coming back down, making its way into the Gulf. Pretty cool to see.
We have healthy chamber pressures on 5 out of 6 ship Raptor engines.
Great news there for Starship.
Super Heavy.
Once again, we were not going to bring the Super Heavy booster back to the tower. We were planning on having it land in the Gulf.
Super Heavy.
And it looks like the booster ended its mission there in the Gulf, but we've got a ship still flying. Great to see that. Still have 5 out of 6 engines there on S39.
Yes, we also heard good chamber pressures as well on those engines that are lit. We do have engine out capability. We do see that we have one of the RVAC, one of the Raptor vacuum engines that is currently out, but that's okay. Ship is continuing on. Amazing views of planet Earth there in the background.
Yeah, I love the S39 decal there. That just gives the ship a little bit of character. And again, all these great views brought to you by Starlink, of course.
Yeah, obligatory shout out to the entire Starship avionics, camera, electronics team. Did a whole lot of work to get these upgraded cameras. A look inside of the ship's skirt, you can see those 3 center engines ignited. The RVAC's continuing to fire as well. We did see at least a couple engines fire up on booster for that landing burn before we lost contact with it. We should have just a little over 20 seconds to go. We'll see if the burn extends a little bit. For the engine out, essentially you can run your engines a little bit longer or throttle up a little bit more to account for the one engine not being lit. So right now we are standing by for SECO.
No sé si es normal, pero el Starship está descendiendo.
And again, we are continuing to go a little bit longer. Five engines still burning on ship.
Qué lindas imágenes. Muy lindas imágenes.
Coming up on T plus 9 minutes.
Vamos a llegar a los 26.000 kilómetros.
And starting to see shutdown. RVACs have shut down. Sea levels are shut down.
Lo apagó.
Seeing if we can get an update on the ship orbit insertion, but we have shut down again. We did run longer as we were engine out. We were flying with 5 of those 6 Raptors pretty much the whole time.
Ship FTS is saved.
All right, well, we definitely got a ship in space right now.
Vamos a tener el despliegue de los satélites de Starship.
As you can see, the teams are incredibly excited to see Starship there in space. We are awaiting the call out of nominal insertion, so we're going to stand by for that. We can see the flaps moving here, actuating. But wow, the cheers here in the lobby are certainly almost as loud as liftoff was.
Yeah. Man, a lot of action going on. And, you know, we said at the top of the show, excitement guaranteed. And we're only 11 minutes in. We still have a lot more to go here on the mission today. So all objectives are done on the booster. So now all eyes are on the ship as we get ready for our in-space objectives.
Exactly. So like I said, we're still standing by to hear the call out for nominal orbital insertion, but we've got a few minutes before the next milestone. So we're going to continue. We've got some amazing views here of the ship. Wow, it's just that this is our planet. This is our home. As a reminder, the objectives for ship today not only included the separation that we saw, but we're also planning to deploy 20 Starlink simulator satellites, as well as 2 Dodger Dog satellites. That's what our internal teams refer to as our newer satellites. We saw a preview of those earlier. We should see those deployments here in a little bit. We're also hoping to perform a relight of a Raptor engine as well.
Yep, that's exactly right. And the relight will look a little bit different this time. We're hoping to get a little bit of a longer duration. Of course, we got to see once we get there. And that relight won't actually be changing our orbit necessarily, but we're doing it more so as a technology demonstration.
Going to get into payload deploy still.
Volvimos. Ahí estamos
Coming
viendo
up
los
right on the part of the
satélites.
timeline when we
No
were
aparece en
expecting
espacio en el
it. Look
teléfono.
inside a Starship there. Oh, I see a door opening.
Estamos viendo.
Looks like Hal didn't wait. Pez door is open. Just a reminder, we've got 22 deployables in the payload bay today. 20 of those Starlink mass simulators, and then 2 are Dodger Dogs, as we like to call them internally, sitting up their modified V2 Starlink satellites. Those are going to be testing a bunch of components that we're planning to fly on Starlink V3, and we've also got them outfitted with a number of cameras for another tech demo that we're trying out on this flight. We definitely are looking for a way that we can look at Starship's heat shield while it's still in space. You can kind of only see so much from the cameras and the flaps. You can't see everything kind of on the underbelly, and one of the only ways you can do that is if you got something else flying near it. So we're going to attempt to our final 2 satellites going out the door have a suite of cameras on them that are going to be looking back at the ship. We're going to be in nighttime, and so we've got, sounds like we're getting into payload.
Estamos viendo. El despliegue de los satélites. Uy, a ver. Quedan 2. Van a salir. Estamos de vuelta. Van a salir. Y salieron. Por favor, que tengamos imágenes a bordo de ellos. En directo. Ah, este es el bueno, este es el bueno. Y ahí sale uno. Ojo. Ojito. Vamos. Volvimos. Yo vuelvo cuando estén reentrando a la Tierra. Así que nos vemos cuando reentren el Starship a la Tierra. Nos vemos. Nos pusieron la cámara del satélite. Impresionante. Impresionante la imagen. Impresionante. Otra vez. Bueno, ahí estamos viendo como si fuesen auroras boreales atrás de la Starship. Empezamos a ver plasma. Estamos a 3 minutos de reentrar a la Tierra. Y ver el espectáculo del plasma. Ahí estamos viendo un alerón. Me parece que el alerón trasero. Bueno, ahí estamos viendo un azul impresionante. Ahí estamos viendo recuerden que apenas se termina la reentrada y Starship americe. Cortamos, voy a cortar el video, me voy a poner a editarlo. Total, acá en mi país todavía es temprano y nada, a esperar a que reentren. Y si hay momentos que se me corta porque se me llenó el teléfono, no tengo más espacio y no sé si se puede grabar completo, pero cuando vaya por 45 kilómetros de altitud, yo voy a empezar a grabar hasta unos 35 capaz. De ahí hasta 15 y de 15 hasta que se termine. De paso me voy a poner a editar los videos, así que ya libero un poco de espacio. Y nada. Nos vemos.
With earlier, they are standing by to receive this ship. Once again, this is the first flight of our completely redesigned Starship version 3.
Yeah, and if you remember the suborbital flights from a few years ago, this is very much the same regime that we're in here. So we're sub 15 kilometers executing what we call the belly flip maneuver.
Si me alcanza el espacio.
Yes, serial number 8, the first belly flop. I remember it well.
Ojalá.
Just some really amazing views of the Earth as the ship is coming back home. Thanks, Starlink.
Yeah, you can see the aft flap there making minor corrections.
Starship is turning for final approach to landing site.
Look at that turn.
There we go. Minor corrections and a full turn.
Yeah, Starship doesn't fly like an airplane. It's a lot more like a skydiver. Full belly flop on the way down, using those flaps similar to arms to help change the path of the air over you. Coming up real soon. Again, going for a landing burn, trying to light 2 of these Raptor sea level engines.
Vamos a ver si enciende los motores.
Landing burn startup.
No.
2 engines lit.
Fallaron un Raptor. Me queda un Raptor. Vemos la boya. Increíbles imágenes, por favor. Increíbles imágenes. Por favor, increíbles. No, explotó a Starship. Qué lindas imágenes, por favor. Miren la bola de fuego. Impresionante. Siempre SpaceX dando las mejores imágenes. Impresionante.
As weird as it may sound to hear, but it is the truth.
Absolutely wild.
Impresionante.
You know, at the beginning of the show,
we're pretty hyped.
We guaranteed excitement at the beginning of the show, and I'd say Starship delivered.
Absolutely. An incredible day for Starship. That was the first flight of that completely redesigned vehicle. As you can tell, the teams are incredibly proud of what we just saw.
Yeah, V3 definitely showed up. That was amazing.
Yeah, we've pretty happy crowd in the control room behind me, I will say. It's probably the most excited I've seen a lot of people in a really long time. On target landing. Wow. Actually,
Bueno, les quiero decir muchas gracias. Ya somos casi, ya falta poquito para hacer 300 suscriptores. Muy poquito. El día de hoy sí que lo logramos y esperemos que sea así para el próximo lanzamiento de SpaceX. No sé si va a ser el Super Heavy, el Falcon 9 o la Starship Super Heavy. Y muchas gracias SpaceX por las imágenes que siempre nos da en todos sus directos. Recuerden que yo estoy en Google y muchas gracias por ver este video. Y muchas gracias seguir el día de hoy. El siguiente lanzamiento va a ser en 7 días. En junio. Y yo me voy a quedar hasta que apaguen el directo.
Really incredible.
Yeah, there's a lot of people that worked really hard to make things look easy, so shout out to those teams. Now be sure to follow SpaceX on X for updates and more exciting views that we didn't get to show you on today's live program. I have a feeling we'll see some pretty amazing stuff come from those demonstration satellites that we were able to show some initial footage of. Now, if you're interested in more launch coverage, head on over to our profile on X. We also have spacex.com/launches for you to check out for the most up-to-date information. So thanks to all of you for tuning in. We're going to close it out and celebrate with our colleagues. Thank you so much for tuning in, and have a great night. We'll see